right now, one of the deadliest volcanoes in human history, is quietly recharging beneath a modern European city. Mount Vesuvius, the same volcano that erased Pompeii in a single afternoon, is in the longest silence it has shown in nearly 500 years. For volcanologists, that silence is not comforting. It is terrifying. More than 3 million people live within its broader hazard zones around the Bay of Naples. Entire towns sit directly on evacuation maps. Roughly 600,000 to 700,000 people live in the official Zona Rossa, the red zone, where pyroclastic flows are expected to hit first and hardest if Vesuvius erupts again. The stakes are simple. If this volcano wakes up violently, Europe could face one of the worst natural disasters in its modern history. On a clear day, Vesuvius looks almost peaceful, a green, rounded cone rising over the blue water of the Bay of Naples. Tourists take selfies on the crater rim. Vineyards and neighborhoods climb its flanks as if the mountain were just scenery. But that calm shape hides one of the most unstable volcanic systems on the planet. Vesuvius sits where the African tectonic plate is diving beneath the Eurasian plate, a collision that melts rock into magma deep below Italy. Unlike the runny lava of Hawaiian volcanoes, Vesuvius feeds on thick, sticky, gas-rich magma. That magma traps gas, like a sealed soda bottle being shaken. Pressure builds until the rocks can't hold it, and when they finally fail, the eruption is not gentle. It detonates. The structure of Vesuvius makes that detonation even more dangerous. The current cone sits inside the older Monte Somma caldera, a collapsed volcanic structure that forms a ring around the younger volcano. It is, in effect, a volcano inside a volcano, a pressure chamber inside a cracked, older pressure chamber. Everything about that geometry screams instability. The eruption that made Vesuvius infamous happened in the year 79 AD. Pliny the Younger, watching from across the bay, described a column of ash, rising like a pine tree into the sky, and ash falling so heavily it turned daytime into night. But Pompeii was not buried by flowing lava. It was hit by pyroclastic surges, superheated clouds of ash and gas, moving at highway speeds, with temperatures around 300 degrees Celsius or more. No one outran them, no one survived them. Entire Roman cities, Pompeii, Herculaneum, Stabia, were erased in hours. And that was only one chapter. In 472 AD, an eruption spread ash as far as Constantinople, in modern-day Turkey. In 1631, pyroclastic flows and lahars volcanic mud flows killed thousands of people around the volcano. In 1906, another eruption damaged Naples and forced evacuations. The last eruption, in 1944, destroyed villages on the slopes and even melted Allied aircraft on a nearby airfield during World War II. For centuries, Vesuvius erupted roughly every few decades. Then, suddenly, it stopped. Since 1944, there has been no magmatic eruption, marking the longest quiet spell in several hundred years. On the surface, that might sound like good news. But inside the monitoring rooms of the Osservatorio Vesuvius Observatory of Italy's National Institute of Geophysics and Volcanology, INGV, scientists see a different story. The official INGV bulletin currently classifies Vesuvius at green alert level. Low volcanic activity, no eruption in progress. But green does not mean dead. Continuous monitoring has detected low-energy earthquakes, tiny microquakes, subtle ground deformation, and minor changes in temperature and gas flow over recent years, signs of an active but quiet magmatic system rather than an extinct volcano. Long dormancy can be dangerous. As magma cools and evolves beneath a volcano, it can become more viscous and gas-rich, increasing explosive potential when it finally rises again. Vesuvius is exactly the kind of volcano where a long silent interval can load the dice for a more violent future eruption. And Vesuvius is not alone. Just to the west lies Campi Flegrei, burning fields a huge volcanic caldera, stretching beneath parts of Naples and the surrounding area. This system has experienced multiple episodes of unrest since the 20th century, with land uplift bradycism of several tens of centimeters to more than a meter, frequent seismic swarms, and tens of thousands of small earthquakes since 2022 to 2023. Recent scientific work points to accelerating unrest and complex interaction between ground deformation and seismicity at Campi Flegrei, raising concern among researchers and authorities. Vesuvius and Campi Flegrei are not completely independent. They tap into a broader magmatic and tectonic system beneath the Bay of Naples. Some scientists describe them like two balloons connected by tubes. Add pressure to one, and the other can feel the strain. That doesn't mean that activity at Campi Flegrei will automatically trigger Vesuvius, but it does mean the entire Neapolitan volcanic district must be watched as a single, interconnected hazard zone. So what would a future eruption of Vesuvius actually look like? Most people picture rivers of lava flowing slowly down the slopes. That's the wrong volcano. Vesuvius's greatest threat is explosive ash columns that can collapse into pyroclastic flows, fast-moving clouds of ash, gas, and rock that can travel 10 to 15 kilometers from the crater in minutes. These flows shred buildings, burn and asphyxiate people, and bury landscapes under meters of hot debris. The Italian Civil Protection Department identifies a red zone around Vesuvius, where these pyroclastic flows are expected to be most devastating. About 25 municipalities and 600,000 to 700,000 residents fall inside this zone. Official plans call for a rapid, preemptive evacuation of this entire red zone once clear signs appear that magma is moving toward the surface, ideally with 2 weeks to 20 days of warning. On paper, the plan is detailed. People would be moved by bus, train, ferry, car, and special convoys to twin towns in other regions of Italy, with the evacuation expected to take about 7 days. In reality, Naples is a maze of narrow roads, historic alleys, dense apartment blocks, and coastal bottlenecks. Volcanic risk perception studies show that many residents are aware of the danger, but also worry about traffic, crime, jobs, and family ties if they leave. Getting hundreds of thousands of people out of harm's way in time without panic under ashfall, with earthquakes rattling buildings, is one of the hardest evacuation challenges anywhere in Europe. Monitoring is the only way to buy time. The Osservatorio Vesuviano operates dense networks of seismometers, GPS and tilt meters, gas sensors, and thermal cameras on and around Vesuvius and the Neapolitan volcanic area. Continuous data streams are analyzed 24/7 for signs that magma is rising. Increases in the number and depth of volcanic earthquakes, changes in deformation patterns, shifts in gas composition, and thermal anomalies on satellite images. So far, these systems have not detected signals consistent with an imminent eruption at Vesuvius. That is why the alert remains green. But technology has limits. Past eruptions at similar volcanoes have sometimes escalated quickly, with only days or hours of clear precursor activity. False alarms are also possible. Magma can rise partially, causing unrest, then stall or cool before reaching the surface. Authorities must balance the risk of evacuating hundreds of thousands of people unnecessarily against the risk of moving too late. Every year that Vesuvius stays silent, the tension between these two risks grows. If the next eruption is small, it might involve limited lava and small pyroclastic flows affecting only part of the red zone. Naples could suffer damage, but remain mostly functional. If the next eruption is large, it could send pyroclastic flows across much of the red zone, collapse roofs under heavy ash, shut down airports across southern Europe, contaminate water supplies, and trigger a humanitarian crisis, as hundreds of thousands of evacuees need housing for months. The worst-case scenarios are not supervolcanic end of the world. Events like some headlines suggest, but they are more than enough to rewrite the lives of millions around the Bay of Naples. For people living in the shadow of Vesuvius, the volcano is both familiar and distant, a backdrop to daily life, a symbol on postcards, a tourist attraction. Risk perception studies show that many residents believe an eruption is likely and would be serious. But they also rank other issues, crime, politics, as equal or more urgent. That split attention is understandable. It is also dangerous, because volcanologists agree on one thing: Vesuvius will erupt again. The only unknowns are when, how intense it will be, and whether we will be ready when that moment comes. Right now, the mountain is quiet. The alert is green. But under that quiet, instruments are still recording every twitch, every millimeter of movement, every whisper of gas. Silence, here, is not peace. It is pressure. When the next chapter of Vesuvius begins, it will not care about history textbooks, tourist posters, or how long people have lived on its slopes. It will follow physics. The only part of this story humans can change is what happens before that first ash column punches into the sky. If you want to see that eruption as a documentary and not as breaking news from your window, pay attention now, while the only things moving are lines on a seismograph. Subscribe to BayInTube, turn on the notification bell, and stay ahead of the next signal from this sleeping giant. The more you understand Vesuvius before it speaks, the better your chances when it finally decides to raise its voice.